Hello, my name is Claudio Casetti, and I would like to tell you a little bit about our work titled Content Discovery and Caching in Mobile Networks with Infrastructure. In our scenario, mobile nodes store content, advertise it, and provide it to other agents following a publish-subscribe paradigm, while special nodes, called brokers, running on infrastructure devices, let demand and offer meet. Not surprisingly, we call this system Figaro, from the well-known matchmaker character in Rossini's opera Il Barbiere di Siviglia. Agents are organized into colonies, each controlled by a broker. If content is unavailable in a specific colony, its broker can fetch it from another colony with the help of a proxy. Figaro may find application in wireless mobile networks. Think of a public transportation system where bus stops and public vehicles are equipped with access points and are all interconnected. As an example, a colony could be formed by stops and vehicles on a specific bus line. Agents are smartphone apps carried by passengers. When they associate to an access point, maybe while waiting for a bus, they discover the broker of that bus line colony and register with it, providing an ID, their addresses, and a list of content they make available. The content may be anything from pictures of monuments on that bus line to enhanced maps or video clips. Interactions between agents of the same colony lets agents query the broker in order to find a specific content. The broker identifies a potential provider agent in the colony and returns a reply to the querying agent with the address of the provider agent. The requesting and providing agents can then engage in peer-to-peer communication through the infrastructure and complete the transaction. Clearly, Figaro cooperation among agents is crucial. It is only through cooperation that queries can be satisfied, so an important metric of Figaro is the query hit probability. In the real world, however, some nodes may act as free riders, just downloading and refusing to give anything back in return. Or they may even act as disruptors, deliberately attempting to alter the balance between offer and demand. In our work, we introduce and evaluate 3 ways to address cooperation and control the behavior of agents. First of all, a credit policy, which increases when the agent provides content and decreases when it consumes content. Through game theory, we show that selfish users, if rational, have interest in cooperating, so they will provide the content they are asked for. We then introduce a feedback-based mechanism to let brokers identify and ban those agents that do not provide the content they advertise. In the paper, we show that, thanks to selective banning, disruptors have lower query success probability. Finally, we introduce a caching scheme controlled by the broker to even out the load of content provisioning among agents. Agents storing low-valued items can increase their credit by caching highly valued items, suggested by the broker. In the paper, we show that caching improves query success probability and system fairness. At the same time, the increased availability of content limits inter-colony data exchange, lightening the load of proxies and infrastructure. Thank you for watching this presentation. We hope you enjoy reading the paper.